Okay, for this question, it asks you how much sulfuric acid right here will be produced from the reacting. So we start with 8.006 grams of sulfur dioxide. Okay, excess amount of water and oxygen, which means you don't have to take a look at this too. Just ignore this too. Okay, if they are present in an excess amount, don't have to care. All right. So all you have to do is just convert grams of this to grams of sulfuric acid. Okay, this one is easy because I gave you the molecular weight of sulfuric acid and sulfur dioxide. On the exam, on the quiz, you have to do this on your own. Okay, so I just want to save time right here. All right, what do we do here? So first of all, make sure that you know the relationship between the quantitative relationship between all the species. So sulfur dioxide and sulfuric acid. So you have to balance the equation first if it's not balanced. Okay. All right. On the left side there's one sulfur. On the right side is one sulfur. Two hydrogen on the left side, two hydrogen on the right side. So very good. Now oxygen, we have 5 oxygen on the left side. Oh man, 4 oxygen on the right side. So we have to balance this equation. Okay. This is how I do it. There's a multiple way to do this, but I just want to kind of a trick for you. If you see an odd number, usually these are troublesome because odd number is hard to match the odd number on both sides. Okay, so I usually make it as an even number first. I'm going to start with that. Put 2 right here. So I'm going to have 4 hydrogen. I'm going to leave the oxygen to the end because there are too many oxygen here. All right, just start with just something that you can do it right here. So 1 oxygen, 1 hydrogen here, 1 hydrogen there. That's it, right? But there are too many oxygen. Everyone has oxygen. So 4 hydrogen. So 2 hydrogen here. So put 2 in front of sulfuric acid. So 2 sulfur. Put 2 right here. 2 sulfur. Okay. All right. So let's take a look at the number of oxygen here. So 4, 5, 6, 7, 8. 4 times 2, that's 8. Yep, we're done. All right. All right. So the quantitative relationship between sulfur dioxide and sulfuric acid is 1-to-1 ratio. Good. That's it. This is simple. All right. All you have to do, convert gram of sulfur dioxide to moles. All right, using molar mass. Moles of sulfur dioxide to moles sulfuric acid, they're 1-to-1 ratio. Whatever moles here is moles there. Once you get moles here, convert back to gram using molar mass of sulfuric acid. Okay. All right. So the unit that we want is gram of sulfuric acid. We have 8.006 grams of sulfur dioxide. All right. Grams to mole of sulfur dioxide. Put grams at the bottom, moles at the top. Cancel out. Okay. Mole sulfur dioxide to mole of sulfuric acid. They are 1-to-1 ratio. Cancel out as well. Yeah. Moles of moles. Lastly, moles of sulfuric acid to gram sulfuric acid. So I'm going to put mole sulfuric acid at the bottom, grams at the top. Mole cancel with moles, you get grams right there. Do the math right there. So there are too many, like a lot of, quite 3 numbers. So watch out there. So you should get 12.2577134 gram of sulfuric acid. I got that from my calculator. And then I'm going to round them up. So 4 digits, 4 sig figs. There we go. All right. All right. So, I'm going to have you do this on your own, balance all equation. I'm not doing anymore. Okay. So I'm going to give you, the key right here. But what I want to point out here before we go is the combustion reaction. You still remember if you want to make fire, you need 3 components: fuel, oxygen, and what? And heat. And always, you're going to always get carbon dioxide and water. Okay. Well, actually, that's not really true. Right? When you get only carbon dioxide and water, we call those a complete combustion, right? The products are carbon dioxide and water. But sometimes, I think you have seen it before, like in the old car, which is illegal nowadays, produce like the black gas. That is not carbon dioxide. Carbon dioxide is colorless gas. You can't see it. Okay, the black gas right here is actually a carbon monoxide. It comes from the old car because the car exhaust is kind of old and the combustion is incomplete, right? So when you see the a car produce black gas, of course, some of them are carbon dioxide, some of them are carbon monoxide. They mix in here. Okay, so when if you see a combustion reaction in, let's say, in the problem, So most of the time, I'm going to say it's a complete combustion, and it means you get the product of carbon dioxide and water right away. If I say incomplete combustion, you get carbon monoxide and water. Okay. For example, right here, so this is propane right here. If I say, let's do the stoichiometry of 5 grams of methane, how many grams of water do you get? When you write the equation, you have to write if I say complete, if the question say complete, your product going to be carbon dioxide and water, and you balance out. If the question says it's incomplete combustion, it's carbon monoxide and water. And then the balancing equation going to be different, all right? But I'm going to give you the number right here. So make sure you try balance equation by yourself first and check this with me. So 2 right here, 2 right here, 3 carbon, 4 water, and that's it. And the last one, 5 oxygen. The last one, we have 3 carbon, 4 hydrogen, and 7.5 oxygen, or times 2 the whole thing. All right, a combustion of pentane, C5H12, gives out 88.02 grams of carbon dioxide. Assuming the combustion is complete just carbon dioxide and water, how many grams of pentane is used? All right, so pentane, that's pentane. Making fire, so oxygen, heat, and it said complete, you're going to get carbon dioxide and water. Okay. All right, now how many grams of pentane? Well, before we go further, I forgot. So make sure this is stoichiometry. The relationship between the quantitative relationship between all these species is really important. Balance equation first. 5 carbon, 5 right here. 12 hydrogen, 6 right here. Okay. 10 oxygen, 6 oxygen, 16, 8 right here. All right, we're done. All right. So the question asks for the grams of pentane, how much we have to use to make 88.02 grams of carbon dioxide. All right. So the grams of carbon dioxide, these two are totally different units, but they all relate by moles, right? They all relate by mole. 5-to-1 ratio. See that? It's 5-to-1 ratio. All you have to do, take grams, convert to moles. Moles carbon dioxide convert to moles of pentane is 5-to-1 ratio. Once you get moles of pentane, convert back to grams. Okay. All right. Let's do it right here. So grams of pentane, and what we want, what we have, grams of carbon dioxide. So grams to mole first. So just put grams at the bottom, moles at the top, molar mass here. Grams cancel out. Next stop, so moles of carbon dioxide to moles of pentane. So it's 5-to-1 ratio. Watch out. So we're gonna carbon dioxide at the top. So I'm putting carbon dioxide at the bottom. All right. So carbon dioxide at the bottom, 5-to-1 ratio. So cancel out. All right. Lastly, so right now at moles pentane to grams pentane. So 1 mole at the bottom, grams at the top. Okay. And do the math. You should get 28.86 grams. And round them up, 4 sig figs. So there are 4 sig figs here, 88.02. Okay. All right. So college chemistry course in a nutshell. This is what usually happens, right? There's all students. You're gonna see all these faces. I'm the instructor, so I usually at the front. I see all these faces. I'll take a look right there. So we have someone the mouth wide open. She looks confused. This guy also look confused. This guy look around to see what other people going on. Some students have their hand on their mouth, cover their mouth. This guy also look confused. She look kind of scared, a little scared right here. She look horrified. Some students are horrified with the chemistry course. Some students got their hand on their head, confused, and someone is laughing. I don't know what happened there. That's the reaction that we usually get from a college chemistry course. Now, another joke. So let's say, all right, ladies, did you see a cute guy walk in? What are you gonna say? A cute guy. I would just be cool and say, good day. Or should I say, hey? And then he approach you closer and you say, gay. Hello. You get nervous, right? Hey, everyone get nervous, right? So don't be nervous. Everyone, just him. You're nervous. He's nervous. Everyone's nervous. So calm down, take a deep breath, and say, "Hey," or "Hello," or "Good day." Either one. Pick one. Don't mix them up. And lastly, I want to close to this video with this. How others see you is not important, but how you see yourself means everything. You probably have heard that there are like a lot of negativity outside the classroom, outside your house. You walk outside, people look you down, people talk you down. Don't ever believe in those, right? People, sorry, my language, people are shit this day. We're supposed to support each other, but we always bring each other down, okay? But don't ever listen to those. None of them know you. You know yourself best. You know what you're capable of. You know what you can do. Whatever they say, you can't do this, you can't do that, you can only be this, you can only be that. Don't listen to them. You know your best. What you want to do in the future, you can do as long as you believe that you can do it. Okay? And I hope you take that very seriously, because you are the only one who can push you the farthest. No one else can. Okay? And whatever you want to be in the future, go for it. All right? If that's your passion, go for it. Don't think twice. Don't listen to other people. Whatever it takes, go for it. You can do it. Okay? All right, class activity number 4. Question 1, question 2, answer key. You know what to do. All right, let's moving on.